Can you hear me?
Yes.
Okay. Okay. So last class mein what we did was we started off with moles and we discussed that one mole of anything is equal to the same number of particles, that is 6.02 into 10 to the power 23. This number is a constant and it's named as Avogadro's constant, denoted by the letter L. So ये सब करते करते we came to a conclusion of a general formula, that is number of particles equals number of moles into Avogadro's constant. How? I asked you how many particles will 2 moles of sodium have. So you told me 6.02 into 10 to the power 23. This whole number should be multiplied with 2 for 2 moles, right? So we did that and we came up with this general formula. Okay, now moving forward, let's relative atomic mass कर लिया था, formula mass कर लिया था. Now let's do molar mass. So let's start with what molar mass actually is. Achha, basically, if I have a glass of water, okay, and I'm adding salt to it. Salt is what? Sodium chloride, NaCl. And I'm adding 50 grams of salt to my water. This is my mass. And what are my number of particles here? If I want to know 50 grams में कितने particles हैं मेरे पास? What am I going to do? I will convert this 50 grams into moles and then I will use the same general formula, right?
Yeah.
So moles ko I'm going to multiply with Avogadro's constant to find the number of particles. Now your formula is obviously particles equals moles into L. Now let's do a worked example for this. Okay. How many hydrogen atoms are there in this much moles of CH3CHO? How will you tackle this question? पहले तो we'll see how many atoms of hydrogen are there in this, right? So how many hydrogens are there? 3 hydrogens here and 1 hydrogen here?
4.
4. So 4 hydrogens in one molecule of CH3CHO. Hence, अब they are telling you कि अगर 1 मोल में 4 हाइड्रोजन्स हैं, तो इतने मोल्स में कितने हाइड्रोजन्स होंगे? दैट्स व्हाट देयर आस्किंग यू, राइट? You have X number of hydrogens, correct? Do you get this part?
Yeah.
So 1 mole में you have 4 hydrogens. 0.01 mole में you will have X hydrogens, meaning how many number of hydrogens? So what you do is you cross multiply and you multiply 4 with 0.01 and you get 0.04, right? So you have 0.04 moles of hydrogen in 0.01 moles of CH3CHO. Now, if they ask you about the atoms का पूछ रहे हैं, right? And abhi what have we calculated? Moles. Moles to atoms or particles, how do you do that? Use the same general formula. So 1 mole is 6.02 into 10 to the power 23. So 0.04 moles will be X atoms or particles, right? Correct?
Yeah.
So again, cross multiply. X equals 6.02 into 10 to the power 23 whole fraction, whole value multiplied by 0.04. X turns out to be, let me calculate it, 2.4 into 10 to the power 22 atoms. So yeah. Now this next question you will do on your own. And the question is, how many moles of hydrogen atoms are there in 3.612 into 10 to the power 23 molecules of H2O2? So this is your question, and you have 5 minutes to solve it. So it's 6:18 right now. You need to solve it by 6:23. ठीक है, timer starts now.
Miss,
Yes.
can you go up a little? I want to
Sure.
see the other formula, the one we did.
This one, particles equals moles into L.
No, the question below it.
So the question that we solve right now. Here you go.
Yeah, thank you.
Are you done?
Miss, I'm not sure how to do it.
Sorry? Actually, you're not sure how to do it. It's okay.
Yeah.
Let's start working on it together. Acha, this is a reverse, sort of a reverse question of the one that we did right now. So here they're asking you how many moles of hydrogen atoms, keep underlining the keywords in the question, are there in this much molecules of H2O2. Okay? So if they're asking you how many moles of hydrogen atoms are there in blah 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 molecules of H2O2, first you need to see how many hydrogen atoms are there in one molecule of H2O, right? If you know one molecule, only then you will be able to calculate for 3.612 into 10 to the power 23 molecules, right? So for one molecule, you have how many hydrogen atoms in it?
2.
Exactly, two hydrogen atoms in one molecule. So in 3.612 into 10 to the power 23 molecules of H2O2, you should have X hydrogen atoms, right? And to find out this X, you will cross multiply. So X equals 2 into 3.61 to 3.1612. 3.612 into 10 to the power 23, right? So now we have X, and this X turns out to be 7.224 into 10 to the power 23. And what is this x? These are number of atoms of hydrogen in 3.612 into 10 to the power 23 molecules of H2O2. सही है? We're still not done with the question. Question is asking us the number of moles in the number of hydrogen atoms in this much molecules. So we have the number of hydrogen atoms in this much molecules. Now the second step is to calculate the number of moles in these atoms, right? Correct? What do we need? Number of moles, right? They're asking you how many moles.
Yeah.
So how do you find out the number of moles? Same general formula use करेंगे. This is my general formula. I'll just place in values. So number of particles is your number of atoms or particles. Number of moles is what you want. So I'll take this as x. Avogadro's constant क्या है? 6.02 into 10 to the power 23, right? Or number of particles, what did we calculate? This, right?
Yeah.
So this is 7.224 into 10 to the power 23 equals x into this. So you rearrange the equation. So x equals 7.224 into 10 to the power 23 over L,
Avogadro's
right?
constant.
Avogadro's constant. Exactly. Can you calculate this for me? And the x,
1.2 10 to the
yeah,
power
go on.
46.
To the power? Sure. ये
Miss,
तो
it
कट
says
हो
that on the
जाएगा, right?
calculator. What?
This exponential is going to cut each other, right? Because it's equal. So just divide 7.224 with 6.02. What do you get?
1.2.
Your answer is 1.2 moles of, what was the question? 1.2 moles of hydrogen atoms are there in 3.612 molecules of H2O. Clear till here?
Yeah.
Now we're coming to moles and mass. Okay. So moles and mass. There's this formula. Okay. So in an example, if I say, what is the mass of 0.25 moles of zinc? 0.25 moles of zinc ka what is the mass? So if I want to know this, I'm going to use this formula. And this formula is, pehle from the periodic table, you will find out the AR of zinc, right? That's available in the periodic table. And the AR of zinc turns out to be 65.38, which means that the molar mass, this is your molar mass. Molar mass is basically your AR expressed in grams per mole, right? This is what we've written here. The molar mass of a substance is its relative atomic mass, MR expressed in grams. So the relative atomic mass just expressed in grams. So zinc's AR or molar mass for that matter is 65.38 grams per mole. Say now the question is, okay, 1 mole of zinc has this much mass. So 0.25 moles of zinc will have how much mass, right? This is the question. So either you cross multiply like this, or you use this formula where molar mass is 65.38, number of moles are 0.25, and you get the total mass, correct?
Yeah.
Okay. So let's do a question for this. Iska answer I'm just gonna write here straight away. Okay, next question you are going to do. ये तो बहुत easy है. You will be able to do it very easily. ये भी reverse question है. You need to rearrange the equation. ठीक है? And if you don't want to rearrange it, just put in the values. समझो you need to find out moles ना this time. Mass equals moles into molar mass. Right? They're asking you how many moles. So moles is what you need to find out. Mass they've given in the question. Molar mass also they've given in the question. Just put in these values and calculate. Okay? So how many moles are there in 2.64 grams of sucrose? And sucrose ka formula is C12H11O22, and MR is also given 342.3. 5 minutes. So it's 6:35. You have time until 6:40.
Miss, the MO you give us is the molar mass, right?
देखो here, you need to find out the number of moles, that is X. MR is your molar mass, right?
Okay.
And this total mass is this mass. MR
Okay.
or AR will always be substituted in molar mass and never the normal mass. ठीक है?
Okay. I'm done, miss. Miss, I'm done.
Done. What's your answer turning up to be?
0.0077.
Perfect. So in 0.00771, right? So if I
Yeah.
convert it to standard form, 1, 2, 3, 7.71 into 10 to the power minus 3. Okay. So what you must have done was mass is 2.64 grams, moles are X, and molar mass is given as 342.3, right? So X की
Yeah.
calculation will be X equals 2.64 over 342.3. So X turned out to be 0.00771 or this. Clear to here?
Yeah.
ठीक है. Now we're moving on to empirical formula and molecular formula. Okay, so in chemistry you have two types of formulas. एक होता है empirical and one is molecular. There's the difference between both of these is very stark. So for example, I have a molecule, for example, C2H4O2. ठीक है? This is a formula for ethanoic acid. And this is a molecular formula. So molecular formula tells you the exact number of atoms in one molecule of that substance. ठीक है? Is this telling you the exact number of atoms?
Yeah.
It is, right? It's telling you there are 2 carbons, 4 hydrogens, and 2 oxygens. And what's an empirical formula? It's the simplest whole number ratio of the elements in a compound. So if I were to convert this molecular formula to an empirical formula, I will do what? I will just take the simplest ratio. So C2H4O2 का simplest ratio क्या होगा? 2 ones are 2, 2 twos are 4, 2 ones are 2. So what's the simplest ratio? 1 carbon, 2 hydrogens, 1 oxygen. Get it till here?
Yeah.
ठीक है, so this is my empirical formula. Again, what was the empirical formula? That tells you the simplest whole number ratio of all the atoms present in a compound. ठीक है? Now, on to the definition for this. Number and type of each atom in a molecule. For example, Molecular formula of ethanoic acid. Is C2H4O2. Then coming to empirical formula. The empirical formula is the simplest whole number ratio of the atoms of each element present in one molecule or formula unit of the compound. So there might be instances where your molecular formula is also your empirical formula. For example, carbon dioxide, CO2. This is the molecular formula for carbon dioxide, right?
Yeah.
Now, if I want to know the empirical formula for this, I will just take the whole number ratio, right? So it's one carbon, two oxygens. I can't reduce it further, right? I can, but I won't get a whole number, right? So since I can't reduce it further, my empirical formula is equal to my molecular formula. And when it can reduce further, then the reduced version is your empirical formula. So here, ethanoic acid ka empirical is now we'll be seeing how to calculate the empirical formula. The empirical formula can be deducted from data that give percentage composition by mass of the elements in a compound. What does this statement mean? One more point and then we'll get into the calculation. Organic molecules often have different empirical and molecular formulas, and ionic compounds may the formula is always the empirical. For example, ionic compound can be NaCl. इसमें your molecular formula is also your empirical formula. How? Because you cannot reduce it further, right? Na is also 1:1 ratio, right? Na to Cl is 1:1. You can't reduce this ratio further. So your molecular formula here is also your empirical formula. Now, this statement here, the empirical formula can be deducted or deduced from data that give percentage composition by mass of the elements in a compound. This means that if they've given you data, for example, if I have a compound H2O and they tell me water is 60%, oxygen is 40%, this data should be enough for me to calculate the empirical formula. So let's look at an example of this. Determine the empirical formula of a compound that contains 10 grams of hydrogen and 80 grams of oxygen. So they've told us that in the whole compound, this is a compound, and in this compound you have 10 grams of hydrogen, 80 grams of oxygen. It's the same as saying you have 10% hydrogen and 80% oxygen, right? Just a difference of units. This one's expressed in grams, and I was talking about it in percentages. So how do you go about this question? There are steps as to calculate your empirical formula. I'm going to write them here. Divide each mass by the respective atomic mass. Then divide by the lowest figure to obtain nearest whole number ratio. And then you get to the empirical formula after rounding off or rounding down. Let's implement these rules. So what they've given us in the question is mass of hydrogen and mass of oxygen, right? ये दो चीजें हमारे पास हैं, and hydrogen they've told us is 10 grams and oxygen is 80 grams. So the first step that I wrote was to divide each mass by the respective atomic mass. So divide each mass by the respective atomic mass. 10 divided by 1 because hydrogen's mass is 1. And 80 divided by 16 because oxygen's mass is 16, right? How do you know the mass? From the periodic table. सही है? Okay?
Okay.
So once you're done with this, what's the second step? Divide by the lowest figure to obtain, what did I write here? Nearest whole number ratio. ठीक है? Now divide by the lowest figure. What do you get from here? You get 10. And here you get 5. So you divide this by the smallest number. What's the smallest number? 10 or 5?
5.
5, right? So you divide both of these numbers by 5. So 10 grams divided by 5 and ये वाले number, sorry. You have 10 and 5. Smallest number from this is 5, right? So you divide both of these numbers by the smallest number. So 10 divided by 5 and 5 obviously divided by 5 itself. Correct? Now what do you get? 10 divided by 5 gives you 2. 5 divided by 5 gives you 1. This is your smallest whole number ratio. So what's your empirical formula? Hydrogen ke column mein we get a 2. Oxygen ke column mein we get 1. So your empirical formula is H2, and since oxygen is 1, we write O. This is your empirical formula. Understood till here? We'll do another example right now. Understood?
I think so.
Okay, let's do another example, maybe then clear ho jaye. So in this example, instead of mass, they've given you the percentage. It doesn't make a difference while you're calculating it. So the question is, determine the empirical formula of a compound that contains 85.7% carbon and 14.3% hydrogen. Applying the same steps, first make 2 columns of the elements that you have, carbon and hydrogen, right? अब following the same steps, पहले हमने क्या किया था? We divided these numbers by their atomic masses, right?
Yeah.
Let's do the same thing. Carbon में they've given us 85.7%. And hydrogen they've given us as 14.3%, right? The first step is to divide both of these numbers by their atomic masses. So step 1, divide by atomic mass. So 85.7 divided by 12 for carbon and 14.3 divided by 1 for hydrogen. ठीक है? Wait, I'm getting the call. Okay, so the first step is done. Clear till the first step?
Miss, where'd you get 12 from? Is it the...
Periodic table.
Okay.
ठीक है? Periodic table में you have carbon. Carbon के नीचे लिखा होगा atomic mass will be here. Proton number will be here. Remember when we were doing isotopes, atoms, etc.?
Yeah.
Remember?
Yeah.
So यहाँ पर we have the proton number and here we have the atomic mass. ठीक है? So what you do is these numbers are given by the examiner. The percentage or the mass is given. So the first step is to divide by the atomic mass. And we've divided. ठीक है? So what's the answer that we get here? 85.7 divided by 12 gives us 7.14. And here we get 14.3 again. ठीक है? Clear till here?
Yeah.
Second step is to choose the smallest number from these two and divide these numbers by the smallest number. So the smallest number is 7.14. अब दोनों numbers को divide by the smallest number.
So 12.
So the smallest number is 7.14, na? So
Oh, I'm saying the
7.1,
first one is 12.
sorry, come again.
85.7 divided by 7.14 is 12.
Yes. But what we've done is 85.7 divided by the atomic mass. Atomic mass is 12 for carbon, right?
Yeah.
So we divided 85.7 by 12 to get 7.14, right?
Yeah.
This is what we did in the last question. 10 divided by the atomic mass. So we got two numbers, We choose the smallest number from this, right? So we got
Yeah.
10 and we got 5. So we chose 5 because 5 is the smallest, and then we divided 10 by 5 and we divided 5 by 5. That's exactly what we're doing here as well. So smallest number turns out to
Oh,
be 7.14. So 7.14 divided by 7.14 and 14.3 divided by 7.14. सही है?
so 1 and 2.
Yes, 1 and 2. This is your simplest whole number ratio. So in the carbon column, you're getting 1. And in the hydrogen column, you're getting 2. So your formula is 1 carbon, 2 hydrogens. This is your empirical formula. सही है?
Okay.
ठीक है, now we'll continue with molecular formula calculations in the next class. Okay?
Okay.
See you. Take care. Bye.
Bye, Miss.